Right. So yesterday we learnt so many things, levels of database abstractions, and what is a DBMS in a simple view, what is data, what is information, right? Now we learned some concepts there, even how we can store the data in Excel. How we taken a more examples for a hospital related uh, information, and we plan and how it will work. We learn in real time how the data will be stored. We learned in a different applications, different softwares, different websites, right? Just how a data will store, where it will store, that we learn theoretically, right? Now we'll today we'll see more about DBMS and how it comes like RDBMS. What is that the difference between DBMS and RDBMS, and what are the tools will be there in DBMS, and what are the tools will be there in RDBMS, and what are the need for a database management system, and how it will move on to a RDBMS. That one we'll see. So today the theoretical concept will be ended, and from tomorrow onwards we'll focus on MySQL. Okay, and we'll create the database. We'll create table. We'll insert the data. How to insert the data? How to use the software? How to use that software? We'll see everything Monday. Okay, today Friday we'll see the concept of the difference between DBMS and RDBMS, and the advantages, and what is the relationship, that is like relational database model. Okay, we'll see here. So basically DBMS means what? As we know, that database management system, right? So which it will stores and manages entire data, right? See, like if you take in previous days, if you want to collect any information, so we'll use paperwork, manual process will work, right? That's a big complex process. Now computerized software has been designed so that all multinational companies, they are like easily accessing their data with the help of some software, right? So even Amazon, Flipkart, IRCTC website, all MLC companies, which it has their own data, it maintains large amount of related data, okay, for their users based on the requirement, right? So that all things will be stored in somewhere, and they can easily access that, they can manage that, they can modify that, everything. Okay, now we'll see here what RDBMS, DBMS and RDBMS. See, like RDBMS is a relational database management system, and both comes under a software systems to manage and to update and to access the databases. But there have a slight difference between that. We'll see that. Okay. In there will be a differences like between databases, DBMS and RDBMS will be there with different aspects. Okay, one aspect is comes under data structure. Now in data structure, how it will be there, whatever the data we are storing, we are maintaining that. Okay, we are collecting from other sources, from other applications, or from other users, will have their own structure. There will be a structure, right? So without that structure it's very difficult. Okay, now we'll see here the data relationship. Second one is a relationship. Now how the data will be stored in that. So how the data will be stored in both the DBMS and RDBMS softwares. So that it says like is there any relationship between two tables or two contents? Is there any conditionals like that? Now query language will be there, one more query language, right? So this is like what there should be a language to access the data, there will be some language to insert the data, there will be a language to manipulate the data. So some language should require, right? So that's like comes under query language. In another aspect like data flexibility, if you take like while the storing of information or while retrieving the data, either structured or unstructured data, if you take, okay, the data can be stored, right? So that whether it is stored in a proper way or not. Okay, that comes under flexibility. We'll see integrity. in aspects of data integrity, there have some rules. There will be constraints which we need to follow to enter the data. In that aspects, what is the difference between that we'll see, and scalability. Now let me go with here DBMS related difference. Okay, what DBMS in different aspects? I mentioned 6 points in data structure. How DBMS will be there? We'll see that. See, it can manage like structured data. It will manage, and at the same time, unstructured data it will manage. Both it will manage in DBMS, database management system. Okay, so it does not require the data to organize in a specific way. They can maintain their own way. So every application will be accessed the data which is structured, which is unstructured data. So every application will access that. So there won't be a standard format. There won't be a like organizing methodology for a DBMS. Okay. Whereas if you take for data relationships, okay, here there won't be a support. No support, like no support will be there for connecting with one table with another table, or one data with another table, other data. Okay, there won't be a relationship between two data elements. Okay, so now if you take another possibility, that an aspect query language. Now there will be a query language based on the applications what they are using and how they are storing. And each and every application and each and every platform has their own different languages to insert the data, to retrieve the data. See, if you are using a file, if you are storing a PDF file, or if you are storing a images files, so basically you can store in a folder, or you can store in a hard disk, right? You can store in a name wise, or you can store in a date wise, date modified size, like size order. So you can store some information in a folder, right? That's like a we'll say like there will be a different languages which can varies in a application size. Okay, now we'll see data flexibility, more flexibility than the RDBMS. For this DBMS will be there, the storage and the retrieval process is very easy, and it can manage unstructured or semi-structured data. Okay, it can manage us both. And if you take here data integrity, so for this there won't be a rules, there won't be a referential integrity constraints for data integrity. Won't be there with rules. Say if I want to insert the data, I can insert. If I want to insert another second data, I can insert. Okay, but there will be a unique data should be present, and it removes all the duplications. And here no integrity constraints will be there for DBMS. Okay, if you take scalability aspects, like handling of wide range of data, if you take different data types, if you take binary data, if you take text data, if you take number data. Okay, so it can handle wide range of data. See, if data is increasing, automatically the storage also can be increasing, right? So that's scalable, based on the data, based on the size of the memory, that can scalable. So comes under like DBMS. So okay, we'll see now RDBMS, how it will be there. So if you take in aspects of data structure, the RDBMS will maintain only structured data. Okay, structured data will be there, which can organize it into tables format. So a tables can have rows and columns, right? So we will have a strict structure, so that all the relational tables will maintain a proper way, right? If you want to insert any data, if already data is there with the number 1, then again and again we cannot insert the data with the same number 1. Okay, we can choose a number 2 and we can insert the data. So there will be some rules which it maintains the structure. So there will be a structure for RDBMS to store the data in a tables. Okay, now we'll take in data relationships. Here it supports there will be a concept called joins concept. So in RDBMS, so table to table connectivity we can make with the help of join commands. So we can get more data we can build complex queries. We can get two different tables data, and we can form in a single table. That things it is there. That is like data relationship aspect. If you take means, so it maintains a relationship between two tables, and we can access that easily, and we can put it in another table also. That is what possible in a data relationship aspect. And for query language support, if you take RDBMS will be there with SQL support. You know that SQL is nothing but a structured query language. A language is meant for to create a database, or to create a table, or to insert a values, to manage the user. For everything, there will be a language for RDBMS software. By using that language only, we can store all the information. If you want to uh, retrieve the data, or if you want to change the data, so we need a powerful language, right? That powerful language will works for relational databases called SQL here. One more data flexibility we'll see. For RDBMS, there will be a rigid structure of tables with predefined columns. If you take first column, there will be a specification, and there will be a constraints column will be there, and default will be there, null column will be there. Okay, there will additional add-on columns will be there. See, some predefined columns will be there. You can give a column with structured data with a good relationship between two tables. It is possible with the help of SQL. Okay, and less flexibility will be there when compared with the DBMS. This is less flexible and RDBMS. Okay, so there will be predefined columns, like, so that it's not good for storing a data, right? For in some sort of cases, but not all. Now data integrity, if you take means, in RDBMS, it is there, more number of constraints will be there. There will be a foreign keys concepts are there. It is there, like unique constraints will be there, check constraints will be there. Like constraints, more number of constraints are enforced here in this RDBMS, so the data can be maintained accurately. And if you take scalability also, like it is well structured, and it's suitable, and it can access any application. You can access the databases, and consistency also that can be maintained. The integrity of data also it maintains. Okay, so it is also a scalable. So like when the data has been increasing day by day, it can maintains their own space for that. Okay, so what I can tell for the entire differences between DBMS and RDBMS. So the powerful when compared with these two, see, some companies will prefer some sort of software, some sort of database system. Some companies will prefer some database systems, like they'll prefer RDBMS, they'll prefer some DBMS. See, based on the company and based on the requirement, they will choose which database they need to maintain. Okay, so now we'll focus on only RDBMS, not on DBMS. Okay, now we'll see here, an RDBMS is a specific type of DBMS. So please note it down this point. This is a specific type of DBMS which focuses on managing the structured data. I already mentioned the point. It just focuses on the structured data only. Okay, there will be a table, there will be a column, there will be a rows which can be identified very easily. That's called what structured data, which is in a like organized format. We can say called structured data by using relational model. And if you take one more point, I can say that an RDBMS, like it's a one type of software which it will help. Let me go to some point. Okay, it is ideal for not seeing this. Yeah, so ideal for applications where the data is highly structured, and the relationships between the data elements need to be maintained and enforced. So last point, I just now I conveyed that we can maintain high level data in a structured format. Even we can maintain a relationship between two tables by enforcing some constraints. We can access whatever the data we want. Okay, so this is a simple difference between that, and we'll go with one more also. What are the tools we'll use in DBMS and RDBMS. Okay, let me go with here. Okay, now DBMS and RDBMS are typically implemented using variety of software tools and systems. So if you take both DBMS and RDBMS, there will be different kinds of tools will be implemented. So you can use which tool you want. You can use based on the company, based on the your requirement. You can use different tools. Okay, one is here you can say tools for DBMS. We'll see what are the different tools are there. First one is SQLite. So we know SQLite is structured query light, right? It's a lightweight serverless DBMS, we can say, which is embedded in all mobiles. It is embedded in all mobile applications, even for desktop, some desktop applications and some small scale web applications. This SQLite will help a lot. The SQLite means what? That is one type of a database tool which stores our information. I'll tell you one best example. We know WhatsApp, right? So we are using the WhatsApp. Whenever we are chatting, whenever we are sending a messages, a content or images, whatever it may be, the entire content will be encrypted and it stores in SQLite only. SQLite is a tool for DBMS. Whatever the messages we are sending through a WhatsApp, that messages will be stored in SQLite database only. Why that it is suitable for mobiles? Mean that is lightweight. It won't occupy more space. It won't have like installation process, everything. So that's so that it's called like serverless DBMS type of software, which is embedded in a mobile applications. So like while developing any mobile application, like by using Android Studio, there will be a database which we can use called SQLite. Okay, we can connect our front end application with Java, whatever you are doing, and we can store the details in SQLite. So that is predefined, it is there. Okay, so this is like what SQLite is one side of one type of tool for DBMS. Second one, if you take Microsoft Access, which it is comes under Microsoft Office, right? So Microsoft Access is one type of application which is there in Microsoft Office suite, right? It is a package. Basically, Microsoft Office is a package. That is not a software. That is a package, right? Or we can call it as a suite. Suite means what? There will be a collection of applications which it will perform their own things, right? Based on the application's requirement. Like if you want to perform any letter writing or circulars making or any notices or notes creating, we can use Word. Like Access also will be there one application which it will help to store the data, so we can, but it can help for only small to medium size applications only, but not major applications. Okay, to maintain any sort of information, we can use for a small side application Microsoft Access. Okay, now then third one is a like MongoDB. Okay, MongoDB is also a one tool which comes under NoSQL DBMS. Basically that is a document oriented and designed for handling unstructured or semi-structured data. So MongoDB also will help to store the information. It is also a DBMS software tool uh, which we can store in the form of documents. So JSON format we can use, right? So document oriented format we can store our unstructured data. Now Redis, it is there one more. It's a high performance which is specially designed for distributed data with focus on fault tolerance. Okay, which can be helpful for catching real-time data. If you want to collect any real-time data, we can use for Redis tool will help to catch the real-time data. Okay, now we'll go with CouchDB. That is like another NoSQL database management system, which is especially designed for distributed data. Okay, see, these are the tools some companies they will prefer, some companies will they will use, right, based on their requirement. I am telling and again that based on the company, based on the requirement, the tools can be used. Firebase, if you take for last one, Firebase, that is basically a cloud based DBMS, right? So which is used in mobile phone and web applications for real time data synchronization and authentication. Firebase is also a one type of cloud-based DBMS software to store our details. Okay, so these are the different tools for DBMS. Let's go with one more called tools for RDBMS. We'll see. Okay, here I am just going with first point, that is like MySQL. So we'll learn basically our course is meant for only MySQL. See, like these are the important things when you are facing any interview on MySQL. Definitely will get a question like what are the different tools uh, related to RDBMS. See, I think if any IT peoples are there in this session, definitely they will tell Amazon RDS we are using, sir. Microsoft Azure SQL we are using. IBM DB2 we are using. Oracle we are using. MySQL we are using. Definitely these are the important tools they are using. So we are discussing that. Definitely there will be a question like, do you know about MySQL? Yeah, I know about that. I can build queries, I can store our data, I can connect applications, I can store all the information from application and push it to a database. We can tell openly, right? Like the same, all the different tools will be there to store the data. These are the tools: PostgreSQL, Microsoft SQL Server, Oracle database, IBM DB2, MariaDB. There are the different tools are there for relational database management system. Okay, and basically MySQL is a open source, right? Open source software, widely used application. This is widely used tool mainly for web applications, and it can perform very high speed and gives real reliability. Okay, now one more second tool is called PostgreSQL. This is also a open source RDBMS software which is developed by, what I can say, like uh, PostgreSQL, which can have good features, and it supports for complex data types only. Okay, that is like PostgreSQL. And Microsoft SQL Server, if you take, developed by Microsoft company, and mainly focuses on enterprise applications, the business applications. It mainly focuses on that. If you take Oracle database tool, we know that some of the universities and colleges, they are using Oracle 10G or 11G software to do their transactions, to store some data and to connect with applications. They are using that Oracle database. So Oracle database is basically a enterprise level, right? So organization level, we can say, business oriented, we can take. So it maintains long history, and good features are there. That is basically a GUI based. That is there will be a command based also inside that. We can browse the tables, we can create a table without writing a query by using GUI support. That's Oracle database. Another one is like IBM DB2. We can take a database too. That is a family of database management tools. We can take data management products will be there. That is also one of that IBM too, which it includes both RDBMS and NoSQL. So which is also, that is also used in enterprise applications and even in that environments. If you take MariaDB, that is also a open source DBMS RDBMS software. Basically, this one will be there with MySQL 4, which is a replacement of MySQL basically. Okay, MariaDB. Now, if you take Amazon RDS, so some of the participants, they know that RDS, like which it will maintains the data and which is provided by Amazon Web Services. So which it support different RDBMS engines. So and which it includes MySQL and PostgreSQL, Oracle, SQL, everything that can be supported. So that is Amazon RDS, relational data systems, which it will supported and provided by Amazon Web Services, AWS. So see, AWS, Amazon Web Services will have more number of services. There are 14 services basically. So we can do networking, we can do databases, we can build applications, we can access any applications from there to there. We can manage the systems. We can do a lot of things. There will be a storage space will be there. A lot of services are there. In that there will be a MySQL related support. even we can practice in that is Amazon RDS. Database related things, if you want to perform in Amazon Web Services, you can use the Amazon RDS. Okay. One more tool, we know that Google Cloud. Google is a search engine, right? Google is a company basically. Google.com is a search engine, as we know that, right? So Google Cloud SQL also it is there. So Google provides more good products. Google provide more good products. From among them, Google Cloud SQL also it is there. You know, like Google spreadsheets, we know Excel, right? We know Excel. So like Microsoft will provided Excel, right? So like the same, Google spreadsheets also there. Google Docs documents also there. See, if you know, like if you have mobile phone, you can try open Play Store now itself. Open Play Store. I think everybody is not opening Play Store. Only one student, one participant opened, right? Now try to open Play Store now itself and go with search like their Sheets app. Sheets, Sheets, Sheets. If you search there, it just gives like Google company, they provided Sheets app. So that is basically Excel, right? So like that we can say like Google also will have more products from that. Google Cloud SQL also it is there, which it will it is based on a cloud based RDBMS software. Okay, these also like supports MySQL, PostgreSQL and SQL Server. This also will supports. Okay, and another one, last one is a Microsoft Azure SQL database. It is also a cloud based RDBMS service which is provided by Microsoft Azure, and it supports SQL Server. See, please understand what are the tools are there, like tools for DBMS what and tools for RDBMS what, and we'll mainly focus on MySQL. Okay. See, there are the courses, there are the different courses for if you want to learn based on the front end application, based on the back end data. So we need to choose which tool is best for that application, which tool is best for that company, which tool is best for our project. We need to estimate that, but before estimating that we need to know first, right? Without knowing that what it is, it's very difficult to analyze, and we cannot judge that, right? So first try to understand the basics, then we can go with the different technologies. Now we'll go with another one called what is MySQL. A question will arise now. Yesterday we discussed at this point, this slide, and we stopped, right? Now here we'll see, let me go with here. Okay, okay, it's there. Yeah. Now what is MySQL? We'll see. We know that MySQL is a open source relational database management system. That is one tool, right? First point, that only. What is the use of that MySQL? That is used to store and manage the data which it is in a structured format, right? I discussed the point and difference between DBMS or DBMS. And one more I told, that it's a popular web development. It supports for web development also, right? So MySQL is a database which it will support to web development also, which stores the data. That is what I can say. Okay, let me go with one more. What are the different before going to that, we'll see need for DBM. What are the need? What is the need of DBMS? We'll see. Okay, just we know that DBMS is a very useful and convenient way to handle and manage the structured data, right? Like unstructured data. Okay, so like it can help to create a structured database and unstructured database in a different way, right? And which is helps to analyze and store. We can modify, we can remove unwanted data. If you don't want that, we can use. Now what are the different like it's their advantages. Okay, so what are the different advantages for DBMS? It is there, it just minimize the duplications. Okay, and it just gives you good result, and which stores the it just gives good storage space. If duplications are not there, it increases the storage space, right? Like user can also give good get results, accurate results, and we can make good queries on that. Hmm? Any change made, if you easily means it, that can be updated in database. See, these are different database management systems advantages. I will see what are DBMS in depth. Okay, so what you understand from between DBMS and RDBMS? See, DBMS basically that maintain two formats, but whereas RDBMS will maintain in a structured format. and which stores in a tables, which stores in a data, which stores in a tabular format. Okay, so now if you take but a DBMS cannot make a relationship between two tables, right? It's very difficult to process. If you want to retrieve the data from one table, we can retrieve. If you want to connect the two tables, we cannot connect, which does not have a proper structure in DBMS, right? So now we'll see here, there will be a different components of database. Before discussing about the components of database, we'll understand what is a relationship. We just given a point called RDBMS, Relational Database Management System, right? So what is a relationship? So we know that in RDBMS, the term it is their relational database, right? So whatever the data we are storing in a set of database tables, and we are linking the table with another table. We are making a relationship between one table with another table. Okay, there will be a common field in one table, and there will be a one more common field in that another table. By making connection between the two common fields or attributes, we can join the two tables and we can retrieve the data. Even the large data or like complex data, we can make a relationship between the two tables. We can make a establishment of a two table common fields from the two tables, and we can access the data. Okay, so there will be a features of the RDBMS. First feature I can say, like each and every column will contain a same kind of data. Okay, so even there will be a relationships, and all the rows, whatever there the rows, it will be there with the distinct values. Okay, now we'll see, we just learnt about what is the relationships. Okay, we'll see then what are the three different types of relationships in RDBMS. Okay, so we'll close the theoretical part as soon as, but we, without understanding the theoretical knowledge, it's very difficult to process to build a queries. So try to understand this also. Okay, these like the three, there are three different types of relationships in RDBMS. We learned what is relationship, right? Now we are going with another concept called types of relationships in RDBMS. See why we need this type of relationship. See, if you are connecting two tables, if you are joining three tables, so if you are accessing the data between that tables, then we need to know that how many different types of relations we can build with the database, with the table. Okay, that we are learning. What is there first here? One-to-one relationship. Okay, there are one-to-one relationship. One type comes under that category. What is one-to-one relationship? If you take a table which can be subdivided with some fields, okay, and like which behave as a subset of main table. Okay, it can establish a good relationship between two tables. Okay, now if you take there will be a one entity and there will be another entity, one to one, entity one to entity one. If you take consider, like suppose if you have two tables, employee table, salary table. Okay, so in this table, each record in a table one called employee can have only one matching record in table 2 called salary. Please understand what is one-to-one relationship. What is one-to-one relationship? Just connecting a two tables and finding a common field in both and matching that. Okay, in first table will be there one common field, second table will be there with one common field. So one matching record will be there in another table. That's like what? One-to-one relationship. I am telling about the employee and the salary. So if you take the employee table, there will be an employee number or employee ID. If you take salary table, there will be a net pay, PF, gross pay, grade pay, basic pay, and including with the employee ID or employee number. Now, if you take employee salary tables, which one is common here? Employee number is common. Employee number in the sense like not a phone number, That is an ID. That is an ID, employee ID, right? Now, if you take, will anyone give one more best example for one-to-one relationship? I'm expecting answer from my participants that. Will you anyone give a one-to-one relationship example?
Students and grades. Class.
Yeah, students and grades table.
Student, grade.
Yeah, student and grade. Okay, fine. That one also we can make a one-to-one relationship. Any other?
Student.
How it will
Yeah.
create?
Name and date of birth.
Yeah.
Student grade comes under 2, sir. I think one-to-many relationship.
I'm
Employee and
expecting
designation.
nice answers. Yeah, tell me. You take
Name and
one-to-one
date of birth. Designation.
two tables తీసుకోండి participants, two tables consider తీసుకోండి. Two tables లోను one-to-one relationship అనేది క్రియేట్ చేయాలి. అంటే సేమ్ ఫీల్డ్ ఉండేలా చూసుకోండి. అప్పుడు ఈజీ అవుతుంది.
Sir,
Name and
Yes,
date
sir.
of birth.
Citizen
and Aadhaar card number.
sir,
Citizen.
ఇప్పుడు వన్ టు వన్ డేటా అంటే మనం ఇప్పుడు బ్యాంక్ అకౌంట్ నంబర్ పర్సన్ సేమ్ ఉంటుంది కదా సార్?
Yes, we can take that. Good idea, sir. If you take a bank account, every person will have only one account number, right? One account. If you take SBI, we'll create only one account in that. Forget about joint account. We will have one account.
వన్ టు
Can we
వన్
take that one-to-one relationship?
Citizen and UID number, sir.
Yeah, we can take. Yes, correct. Aadhaar card number we can take. See, if you take for this table, good answers. I appreciate.
Either PAN and Aadhaar, sir.
Yeah, PAN and Aadhaar also we can take. PAN card details table and Aadhaar card details table we can take also. That's also fine. A person related. Fine, good answers. Now we'll see what I am going to tell for one-to-one relationship for employee and salary. There will be salary details of each and every employee or different with respect to their common fields, right? So that's what I can say for one-to-one relationship. Whatever the examples you given, that is a match for that. We'll see with one-to-many relationship. We'll see one-to-many relationships here.
Here, student and grades, sir. Student and grades, because we can see many subjects grades at a time with the name of the student.
Very good point. Yes, one more stream and student, correct? Group with student, can we take that one?
Sir, mandal and villages.
మండల్ సూపర్ సార్. రైట్, ఒక మండలంలో బోల్డ్ అని విలేజెస్ ఉంటుంది అలా అనుకుంటున్నారా సార్? అంతే కదా
సార్? ఒక ఆర్గనైజేషన్ లో ఒక హైయర్ అఫీషియల్ తో అతని కింద చాలా టీం ఉంటుంది కదా సార్?
ఓకే, టీమ్ లీడ్ విత్ మేనేజర్ విత్ టీమ్ లీడ్ అండ్ టీమ్ లీడ్ విత్ సబ్ మెంబర్స్.
అవును సార్.
వరల్డ్ కప్ అండ్ ఎయిర్ కోర్స్.
సూపర్ సార్, నైస్ ఎగ్జాంపుల్. ఎనీ అదర్ ఎగ్జాంపుల్?
Teacher and students.
Oh, this is very nice. Teacher and student. Only one teacher will be there with many number of students. We can take that, right? So this like comes under one-to-many relationship.
Sir, village and pin code or city and pin code?
Village and pin code, city pin code.
Anything, place and pin code.
Yeah, we can take that one-to-many. Yeah,
Sir,
good.
educational institutes and faculty.
Educational institute and faculty. Okay, one-to-many.
Faculty ID only.
Yeah. Very good,
Not
sir.
with names.
Nice.
Same apartment, different flats, sir. Same apartment, single apartment, different flat names.
Yes, correct.
Book and pages.
Book and pages, nice. Okay, good. Thank you for giving interaction with me with different answers. Good. Now everybody please understand what our participants are telling with different examples. They are very nice. They are telling more examples. So to activate you, to guide you, to just get a clarity on that, they are also giving more examples. Now focus on the concept. Are you listening now? What is the previous concept I told? What is the previous slide I just given information? Can anyone?
Sir, one more. చెప్పచ్చా?
Yes, sir. Yeah, చెప్పండి.
ప్లే స్టోర్ అండ్ యాప్స్.
ఇంకా బాగుంది ఇది. ప్లే స్టోర్ ఒకటే ఉంటుంది, బోల్డ్ అండ్ యాప్స్ ఉంటాయి, అంతేనా సార్?
ఎస్ సార్.
Okay, good depth knowledge. Yeah. What is the previous concept I told now? One-to-many
Components of the
one-to-one relationship చెప్పక ముందు ఏ కాన్సెప్ట్ చెప్పాను?
relationship.
Perfect. Just I expected that only. Relationship. Now relationship means what? Just combining two or more tables and accessing the data. That's what. Yeah, but making a common field with that. Now we'll see many-to-many relationship. Many-to-many relationship. We can take company, sales,
Students and subjects.
students, subjects.
Shopping malls and peoples.
Okay, fine, good. Products, purchasing a products with many peoples, right? People's we can take that also. Customers and products. We can take many things, many more and more will be there, right? So that's like comes under three different types of relationship.
Countries and capitals, can we take, sir?
We can take, madam. Sir,
వెబ్సైట్స్ అండ్ లింక్స్ సార్.
websites and links also we can take. We can analyze. See, for a statistics purpose, they required that how many websites are there, and in a website, how many links are there with the titles, with the button, how many number of buttons are there. With the button, if you click, there will be a link which is rendered. So how many buttons are there, how many links are there, with whether it is mapped or not, many to many. We can take that also, right?
ఓకే సార్.
Sir, I have a small doubt, sir. Here you have given one example, that third one, many-to-many relationship. Example is a company sales.
Yes, madam.
Here-
Company and
here-
sales. See,
Yeah,
for
company is singular and sales are different, no, sir. So,
More products maybe.
for
so
products
many
will
to
be
many.
there. Many to many relationship will be there. Like there will be unique fields. We can take part ID and stock ID. Stock ID in sales company, there will be a part ID will be there. Parts name will be there.
But,
Quantity.
but company is the same, no, sir.
Ma'am?
But company is the same.
See, for
How
all
it
the
comes
companies,
under
if you
many?
take more companies, if you take the company,
Yeah.
then more companies will sales. Every company will have their own sales. If you
So
take-
here what I'm asking,
ma'am.
instead of a company, can we make it into companies?
Okay, fine. Okay, yes, sales. Yeah, fine. Good.
Thank
Companies
you.
with sales. We
Yes.
can make that also. That is also.
Company, different products and sales.
Yeah, we can also take like that.
Then that comes under two, sir. What she
No.
said, the company sales comes under two, one to
One
many.
single entity, one to many will come. Companies with sales comes under many to many, it will come.
Yes, sir. Yes.
That's fine. Good. Okay, we'll go with another concept then, without taking so much of time. Let me. Components. Okay, so we'll see components of database. What are the different components are there for database? We'll see here. Okay, and then what are the terms are there for RDBMS also we'll see. First one is a table. We'll focus on table here. What is a table? It's a like structure which is inside a database and formed by using a rows and columns. So as we know, Excel, if you take A1 data will be there, B1 data will be there, C1 data will be there, D1 data will be there. Like the same, like A2 data will be there, like A3 data will be there. If you take all 4x4 or 3x3, 10x10 or 6x6, whatever it may be, there will be a matrix format, right? 3x3, if you take 3 rows will be there, 3 columns will be there. Like that, that's like structure. The records will be there, which we can insert some data. Which we can insert some data inside the table. That table will be there inside the database. Okay. Now, which it forms using a rows and columns. Now we'll see row. What is a row? What is a row means? It's a horizontal lines of a table is called what? Rows. A horizontal lines will be there of a table. Call it as a rows. Now what about column? What about a column? A vertical lines of a table is called what? Columns. Vertical lines of a table is called columns. Then what about attribute? We can say attribute, also call it as fields. Okay, or field we can call. See, every column will be their heading, right? Every column will be their heading. that we can say that is a column. Every column in a table has specified with some name, that is called heading. I can say that roll number, name, marks, everything we can call like attributes, or also call it as a fields. Okay, another fifth one we can say like a record or a tuple. Then what is a record or what is a tuple? A row of data. You can say a record of table. We can say a tuple of entire table. We can say called a record. Each and every person will have their own details. If you take number one, will be there with entire data. Number two, there will be entire data. We can say that is a record or a tuple. Okay, so each row in a table consists of a number of fields. So that's the columns which represent the record. If you take the best example, let me go with MySQL, or else if you take here only, let me share something. Okay, there will be a table which it will be there. Okay, I can use something like this, right? If you have some columns and you can say like serial number serial number and like name, and next we can say like marks, and data will be there here and there, here and there. This is like one, this is like two. If you take one will be there with one record. This is like second record, like that. Okay, now whatever there here on top of that is, that comes under headings. That comes under headings. This is like a record. We can say this is a record. So this is a row. This is what like column. The horizontal horizontal lines, we can say it as a rows, horizontal line. For call like columns vertical lines. Okay, please understand that. Now this is what I can say for components of databases. Okay, now we'll see one more concept. Let me go with this. Okay, data types it is there. Like we'll discuss that later. Okay, now is there anything to ask from your side, participant side? A questionnaire session. We'll see questionnaire session. What
Sir, in the table, what is attribute and what is
I will
record,
show
sir?
you, ma'am.
Can you show
I
me?
will show you with a good example. Let me take Excel first. We'll take example Excel. Let me take here. We got Excel now, right? Just I am showing an example to understand to you, right? Now here, if you take something like I'm going with the serial number and name, then roll number, or else I will go with here backside reverse roll number and then name, like this. If you take 1, 2, this is 3. If you take here serial number 101, 102, and 103, I just mentioned. So Raju, Raghu, Rani. If you take some rough data, I'm just taking. This is what I am telling that table, right? This is a table. Basically, this is the table. Now, what are attributes? This is called attributes. Whatever the highlighted yellow color boxes, information, serial number, roll number, name, these all comes under attributes. Attributes. This is the headings for each and every column. Now, this part is called what? Column. A column, B column, C column, like that. Column representation. Columns. Okay. What is a row then? This is a number 2 here. It is there 101 Raju. Then 2 102 Raghu. That is like one more record. We can say record, row, tuple. We can say like record, row, tuple. Here, how many records are there? How many records are there?
3 records.
3 records are there. If you include one more top one, will become 4. But basically, we'll use this is like attributes. Heading part attributes. How many columns are there? 3 columns. Right. How many number of repeated values are there? Is there any repeated values in that?
No.
sir.
No, there won't be a repeated value. Right. If you take this is like number 1. Now we can say this is like already the data is exist. So we cannot insert the values, even though see that there will be a constraint in RDBMS. There will be some set of rules to insert a data. By if you know the constraints, then you can understand that. If the number I just given like serial number has 1, 2, 3, 4, 5, roll number has 101. See, we know that there will be unique numbers for serial number. There will be a unique roll numbers. Everybody will have different roll numbers, right? but names are same. If you take here Raju, Raju will be there. In any organization or in a school or in a college and wherever if you take, there will be two names. There will be two same names, but their IDs are different. If you take Free Gurukul app, in the tab, I think you all are having ID. You all are having ID, but some names are same. If you take example of Anjaneyulu garu, both Anjaneyulu will be there. Their IDs will be different. Okay, in RDBMS there will be a possibility that we can reduce the duplication. Where you can reduce a duplication by applying constraints to a column, to a particular column. Okay, now there will be a 1, 2, 3 here. We can allow it can allow. If you are using like 1 to 1, if you are inserting means it won't allow, even though the names are same or different. Okay, why? Because these two comes under unique data. If you set constraints for these two, it's very difficult to insert same data. We'll learn everything at that time. Now you please understand what is a table. Here table nothing but a combination of rows and columns. 1 point. Second point here, rows, and this is columns, and these are attributes. Attributes also call it as fields. Is that clear, madam? Some participant they asked a question. I think
Yes, sir. Yes,
Yeah.
sir.
Fine.
Yes, sir. Yes, sir.
Yes, fine. Shall we go with questionnaire now?